Again, let's look at friction on horizontal planes. Okay. What are the forces that act on an object when it's on a horizontal plane? I'm going to share my screen. So you've got the notes. You'll be looking at these notes, following with me. But I'm also going to demonstrate these forces to you. First and foremost, we always have the weight of the object acting downwards. Now, Newton's third law says that for every action, there is an equal but opposite reaction. So the reaction to this weight is called normal reaction force. The force that balances the weight is called the normal reaction force. All right. Then if you have an applied force acting to this direction, if you have an applied force acting to this direction, this is an applied force. I want to make my frictional force this side. So frictional force will be acting the opposite direction. So this is the applied force, and that is frictional force. Then there is another force which acts in between the normal reaction and the frictional force. That force is called the total reaction force, TR. Okay? So all these forces are described over here on the notes. Yes, the total reaction force. Yes, the normal reaction force. Then there is also an angle that is here. That angle is called the angle of friction. The angle of friction. Sometimes they ask you to define this angle. To define this angle, you simply mention the position of this angle. You say it is an angle between the normal reaction force and the total reaction force. Okay. Now, let's look at equations that you would use to do calculations for friction on a horizontal plane. The first equation that you will need is the equation to calculate frictional force, and this is given on the formula sheet. It says coefficient of friction multiplied by the normal reaction force. From this equation, you can derive a second equation to calculate the coefficient of friction. So that equation will say coefficient of friction equals to frictional force over normal reaction force. Simple making coefficient subject of the formula. And then thirdly, the equation you might need is the equation to calculate the total reaction force. Now, by definition, it says here a total reaction force is the resultant of the normal reaction and the frictional force. Now, if you look at that, you can use the vector diagram to determine the total reaction. Say you have your normal reaction force up here, and your frictional force is going to the east like that. So that is your frictional force. So your total reaction force runs like that. So that's your total reaction force, TR. As a student who has done mathematics, you can use, say, this force and that force are given, and you're looking for this one. You can use Pythagoras theorem to work out the total reaction force. Okay? Now we know that to make the total reaction subject of the formula, you put a square root on both sides. So that square root cancels with that square. Therefore, the total reaction force will be equal to the square root of the normal reaction force plus the frictional force. Each is squared. Okay. And then if you notice, the angle of friction is between the normal reaction and the total reaction force. So that means it is here on this vector diagram. If you want to calculate that angle with these two forces given, you will use tan. You will say tan theta equals to opposite over adjacent. Then if you look at this, you will remember that frictional force over normal reaction gives us the coefficient. So this is also equal to the coefficient. Therefore, to calculate the angle of friction, you can simply say tan theta equals to the coefficient of friction, because the frictional force of a normal reaction gives you the coefficient. Okay. And then these are all the equations that we can say are given. If you notice, these equations do not accommodate the applied force. If they want us to work out the applied force, we're gonna need an additional equation. There are additional equations that you can derive using equilibrium laws. Using equilibrium laws. What are the equilibrium laws? The equilibrium laws say that sum of the algebraic sum of the vertical components equals to 0. Algebraic sum of the horizontal components equal to 0. What does this mean? It means sum of the upward forces are equal to sum of the downward forces. And this one means sum of the forces eastwards are equal to sum of the forces westwards. If we use this law, what formula can we come up with? It will mean upward forces are equal to downward forces. So it will say NR equals to W. And if we use this law, eastward forces are equal to westward forces. It will lead us to frictional force equal to applied force. So this is the formula that we can use to calculate the applied force. But these are not standard equations. Do not memorize them. They depend on what forces are acting on the object. So this is just a generic sketch whereby the applied force is flat on the surface. Okay, so at N2, the applied force would always be flat on the surface. But at N3, the applied force can also be at an angle. Now, let me do this example with you whereby the applied force is now at an angle. So this example says that a body with a mass of 40 kilograms rests on a horizontal plane. This body rests on a horizontal plane. So let's sketch this body showing that it's resting on a horizontal plane. So here's a horizontal plane. There's a body resting. This body has a mass of 40 kilograms. So a mass of 40 kilograms will give you a weight of 392. So that means it's got a weight of 392 downwards here. And it's got a normal reaction force upwards here. The normal reaction force. Okay. Then they say the coefficient of friction is 0.36. The coefficient of friction is 0.36. Then they say a force T with an angle of 22 degrees to the horizontal pulls the body. Okay. So I'm going to make the force T to pull this side. Force T is here. It's at an angle of 22 degrees. It pulls the body. So if they say it pulls, make it pull. If they say it pushes, make it push. And then it pulls it at a constant velocity. Then they say calculate the magnitude of force T. So if force T is going that way, frictional force will go the opposite direction. So there's frictional force. Now, before you can do anything at N3, you know that if there's a force that's at an angle, you must resolve it. So this force is going to have a horizontal component and it's going to have a vertical component. They are also pulling. So this component is going to be T cos 22, and that component is going to be T sine 22. Okay? With those, now we can calculate. The question says we must calculate the magnitude of force T. I like to consider the parallel components first. It just makes sense to me to do that. Consider the parallel components, which is the components that are parallel to the plane. So if you consider those parallel components, we will say forces this direction are equal to forces that direction. Remember, there's no formula to calculate an applied force. You have to use the equilibrium laws to derive that formula. So this way we have T cos 22 equals to, that way we have frictional force. But remember, frictional force equals to coefficient times normal reaction. Therefore, T cos 22 equals to coefficient times normal reaction. Now we can substitute. What is coefficient? Is 0.36. What is normal reaction? We don't have it. To get normal reaction, we will consider the perpendicular components. What do we have on the perpendicular components? Upward forces are equal to downward forces. So upward, we have T sine 22 plus NR. Downward, we have 392. So this is a force in newtons. So let's make T sine, let's make NR subject of the formula because we came here to look for NR. NR equals 2392 minus T sine 22, okay? So we can substitute that whole expression in the place of NR. So it's 392 minus T sine 22. Then let's work out our values. We have cos 22 here. What is cos 22? Cos 22 equals to 0.927. And then we have 0.36 times 392. It gives us 141.12. Then we have 0.36 times sine 22. It gives us minus 0.135T. So then we take 0.135 over to this side, it becomes positive. It adds on 0.927. 0.135, it gives us 1.062. There's a T, this side we have 141.12. Divide by 1.062 both sides. Therefore, T is going to be 141.12 divided by 1.062. It's going to be 132.881 newtons. So that is how you calculate applied force on a horizontal plane. All right, thank you. So the next video will discuss how to do a calculation